So let us see how the question asks. It is given that vector OP is K4, vector OQ is 1, 3, vector OR is H, negative 2. And they tell you that express H in terms of K. See that? Express H in terms of K if P, Q, R lie on a straight line. It means collinear. So firstly, if collinear means the vector that you can get from either point P, Q, or R, they must be parallel, right? Point P. So this point P will give you K4, right? Vector OQ, it will give you the coordinate of point Q, which give you 1, 3, right? And lastly is vector R. Vector OR, it will give you the coordinate of point H, negative 2. Once we say these 3 points are collinear, it means that this vector, for example, the vector of PQ and PR, and also the vector of QR, you nampak we got 3 possible vectors we can get from here. They are all parallel. So to apply the concept of parallel, we can actually just choose 2 vectors here for us to compare. PQ is PO plus OQ. So which means in order to find the vector PO, we just have to kasi terbalik the K and 4 become negative K and negative 4. Because we need the PO, correct? Plus OQ. So it will give us the vector of PQ, which is 1 minus K negative 1. So that is the vector for PQ. So I already explained to you, got a few methods for you to get the vector, count it. But of course, this one you cannot count because you got unknown. So that's why you got second method, which is PO plus OQ, which is the one that I use here. So the third one to find the vector is use the final point minus the initial point, remember? So the final point here is your Q. Initial point here is your P. I start with X first. 1 minus K, nampak tak? 1 minus K is for X. Then 3 minus 4, it will get a negative 1. Okay, so this is a 3 method for you to find vector. So it's up to you which method is easier for you. Okay, now we pick the second one, second vector here. In this condition, I will avoid PR. Do you know why? It will involve 2 different unknown in the same vector. So that's why we put QR. Okay, if we put QR, we use the final minus initial. H minus 1. See, H minus 1. Then negative 2 minus 3. So negative 5. So with that, we get the 2 different vector already. One is PQ and one is QR. And we know that they are parallel. The changes to y should be the same as the changes to x. How we make negative 1 become negative 5?
Times 5.
Times 5. So in this case, we understand the lambda between these 2 vectors will be 5. This 1 minus k, if you times 5, you will get h minus 1. 1 times 5 is equals to negative 5. So 1 minus k times 5, it will give you h minus 1. Okay, so this one is a shortcut that I explained the other day. You can directly read it from the vector itself. Then you know already what will happen to the x or the y. So I just multiply it. And since I want the h in front, so I move the negative 1 to the front. So I will get my answer. H is equals to 6 minus 5k. With that, I get my h in terms of k. So you can see this question, the most important part is you have to identify which 2 vector you want to try to refer here. So the one I use here is PQ and QR. Actually, you can refer to PR also, you will get the same answer. It's just that the vector PR, you will have 2 unknown inside. The things will look a little bit complicated. Let's say some people maybe they cannot see the relation between this negative 1 and negative 5. For example, because sometimes the question is complicated, right? So they cannot see the number involved there. So if that's the case, then we are going to use another method that I introduced the other day, which is lambda. Okay, so we are going to add lambda between PQ and PR. So I show you here. I write here PQ and PR. So we are going to add the lambda between them. So the lambda will represent the ratio between them. But the thing is now, where you want me to add the lambda? You want me to add the lambda in front of PQ or in front of QR? Okay, I add the lambda here like in front of PQ. Actually, you can put in front of QR also, up to you. I'm putting you got the lambda. The lambda here represent any value between the vector. You know there is a value between them. It's just that you don't know what value is that. Okay, so this is my second method. Okay, what we're supposed to do here, simple, just substitute in. Okay, 1 minus k, and then after that negative 1. QR we substitute with h minus 1, and then negative 5. This method you use it when you are not too sure what is the number that what is the value that you're supposed to multiply here. So as you can see here, we can compare x to x, y to y already. So we compare the y, nampak ah? Lambda multiplied with negative 1, it will give you negative 5. Can you see that? So that will give us lambda is 5. So we are actually getting this value. See that? So that's why I say if you manage to identify the value straightforward, then no need to do this anymore. No need to compare with lambda. But if you cannot, then you do in this proper way lah. Then after you get the 5 lambda, that will lead to the second step, which is you compare the x equals to h minus 1. After this, we are going to substitute the 5 inside here, which lead to this working. So they are the same. Okay, so how to get the 3 marks here? After you identify the vector, if you manage to identify the 5, you will get 1 mark already. Second mark is when you compare the x with the 5 also. The third mark is the answer. Same thing when you use this method. The first mark is when you compare the y with the lambda. This is for you to find out the lambda. Second mark will come to this when you substitute the lambda with 5 here. Is this the only way for us to solve these questions? Because the question is said collinear, right? Collinear means straight line. So if you are using this method, actually many people they cannot do. You know why? They might forgot they need to find the PQ or PR or QR at the first place. They would directly use the vector here, then directly compare with lambda, which is wrong. Because OP, OQ, OR themselves are not parallel. But PQ, PR, QR yang parallel. So that's why we have to find the vector first. Some people maybe they feel that this method is complicated. So now I'm going to introduce to you another way for us to solve this question, but not using the method of vector. We already know the coordinate, right? I already write down for you. One is P, one is coordinate Q, one is coordinate R. Because P, Q, R are coordinate. So PQ, QR, PR, they are all parallel. Now I can actually directly find the gradient, right? Can you see that if I want to find the gradient of PQ, I will get 3 minus 4 divided by 1 minus k. Gradient of QR, it will be negative 2 minus 3 divided by h minus 1. Then I compare it. See that? Then after that, we just have to cross multiply. Can you see that this 4 minus 3, it becomes 1. So if you cross multiply, you still remain h minus 1. This negative 2 minus 3, negative 5. So negative 5, it will be minus with k minus 1. You will get this, h minus 1. So lastly, I move the minus 1 to the other side. I will get the same answer also, which is h is equals to 6 minus 5k. If you manage to get the gradient of PQ or the gradient of QR, you will get 1 mark already. Actually, we can compare to PR also. It's just like I say, PR will involve 2 unknowns, so I don't use it here. But you can use that also to get the same answer. Second mark will be given when you compare. We found 2 gradient and then you compare the 2 gradient. Lastly, 1 mark will be the final answer. Maybe we got another method again can be used to solve these questions, since we already come up with a coordinate like this. Or I can actually refer to the area. Right, you nampak I write down here area of PQR is 0. How come I write down 0 here?
It is a straight line.
Yes, it is a straight line, right? Even though you go to find the area doesn't exist, right? So that's why it's 0. Yes. The third method we can use here is we refer to the area, which is 0. We are going to use Shoeless formula here. So I put in 1, 3, K4, H negative 2, and then 1, 3. Let it equals to 0. And then after that, I substitute one by one using the Shoeless formula. I hope you still remember how to use the Shoeless formula. 1 times 4, K times negative 2, H times 3. Then after that, I move back. 1 times negative 2, H times 4, K times 3. Then you can see minus. Okay, let it equals to 0. Then after that, you just simplify everything. This 1 over 2, if you move to the other side, multiply with 0, hilang already lah. So I will only left negative K minus H plus 6 equals to 0. Hey, did you realize that my modulus gone already? Remember when we learned the coordinate geometry chapter, I always say the modular cannot simply kasih hilang. When you kasih hilang, the other side must becomes positive negative. How come in this question my modular I kasih hilang?
0 is 0.
Because 0 is 0, yes. There is no such thing positive 0, negative 0, no. So that's why it doesn't matter. You can just kasih hilang the modulus only. There is no positive, negative 0. But if other value, yes, you have to consider the positive or negative value. Okay? So with that, we just move the h to another side. You will get the same answer also, which is h is equals to 6 minus 5k. So 1 mark will be given once you substitute the point inside the Shoeless formula. 1 mark will be given once you let it equals to 0. This one means that you understand the concept of the straight line here, collinear. 1 mark will be given for the final answer. Maybe some people still feel that, oh, vector method also difficult. Gradient, compare gradient also difficult. Area equals to 0. I cannot think of that during exam. Let me introduce to you the fourth method here. The fourth method very easy. Draw it out now, like this. See, I label my PQR, PQR, I label it. Okay. Then after that, if you want to use the cross method here, we need to know the ratio, right? We can actually see from the point, you know. We don't look at the x because the x can't got unknown. We look at the y. In Apaka, this one is 4, this one is 3. What is the difference between 4 and 3?
1.
1. What about 3 and negative 2?
5.
5. In Apaka, we already get the ratio between the P, Q, and R. So you know that if they are a straight line, the ratio of R will be the same as the ratio of the X also. So now we can use our cross method. So 5 times k plus h times 1 over 6 is equals to 1. Then you just move around, you will get your final answer. H is equal to 6 minus 5k. They will give you your first mark if you manage to find out your ratio is actually 1 and 5. Okay, this one is n. Both value must come out. The second value is when you apply the formula and you compare with the 1. Second mark will be given when you write down h is equal to 6 minus 5k.